Okay, so we're looking for a maximum area of a rectangle inscribed in a circle. I'm just going to make this a little bit bigger so that we can shrink it later and not run out of room. So here's our circle, and we can put a rectangle in it like that, or like that, or like that, and we want the biggest area. Clearly I need to quantify some sort of measurement, so I want a centre here, and I guess I'm looking at a radius right there. Interestingly, I need to talk about this point on the circle. So there's a point, x, y, right there. And we're thinking that the area of that little rectangle there will just be x times y, which is length times width. Length, which is x, and width, which is my y. And clearly there's 4 of those, so it's 4xy. As with all optimization functions, we know we want to go a dash and set it equal to 0, but we can't differentiate, so we need the connection between x and y. Well, we need the connection between x and y, where x and y is a circle, so you need to know that from grade 11. And we want one in terms of the other, so let's go y equals, and we can just go straight in, 4x root, there we go. We can't exactly expand that, so we're trapped in a product rule. So u equals v equals, so u dash is easy, v dash, that's a chain rule, please be careful. We're thinking r squared minus x squared to the half, yeah, that's what we're thinking, so it's going to be a half multiplied by the derivative of what's in there, multiplied by r squared minus x squared to the negative a half, so that goes on the bottom. So we've got to tidy that up a little bit, otherwise we're going to run out of room. So the 2 and the 2 will cancel, so it's going to be minus x on, so let's just get rid of all of that jazz, minus x on, there we go. Still got room. Okay, so clearly that's u and that's v. So a dash equals v u dash plus u v dash Okay, we are going to add fractions. So when I multiply the top by the root, that's going to undo the square root. The magic of an electric pen. Wow, electric pen, is that what it's called? Okay. A dash, we've got our common denominator, and it's got 4r squared minus 4x squared minus 4x squared, so that's going to be minus 8x squared. And we're going to set that equal to 0. Null factor law, I don't want the denominator 0, So I'm going to end up with 8x squared equals 4r squared. R on 2. And x equals plus or minus, that's r squared on 2. So we're going to be r on root 2. You know, the plus or minus don't really care about because it's optimization. Okay, the question says, what is the maximum area? So I've got to go back to a function that says area equals, and area equals. So let's just go with that. Just rule a line. Area equals 4 times x. X is r on root 2. Root r squared minus x squared. A little bit. So it's going to be 4 times r times root r squared on 2 on root 2. Let's just tidy that up. R squared on 2 is just r on root 2, isn't it? So it's going to be r on root 2. Root 2 times root 2 is 2. They cancel and we get our answer, 2r squared, which is what hopefully you got when you gave it a shot. There you go. That was fun.